So next one we have always statement. So always statement is makes use of the keyword always, and when we make associate with this, we get the always block. So all the behavioral statements which are present within this always statement, that is this term. So this is the always statement. So all the behavioral statements which are present within this always statement are constitute the always block. And the name itself tells that what happens to the statements which are present within this always block. These statements are executed in a looping form. That is, repeatedly they will be executed. Whereas in initial statement, what initial block, what happened? It is just executed only once. Once you start the simulation, only once this execution will be done. But if you start the simulation, always statements will be executed again and again. So it is a looping kind of thing what you have over there. So let us and always statement again starts at time is equal to 0. That is at 0 time unit. Whenever you start the simulation, at that time even the always statements start off. So let us look at an example and see how it goes around. So here we have module clock gen. So some register data type which is defined as clock. Now here we have one initial block. So in initial block, what we are doing, we are specifying clock is equal to 0. Now after that, what we are doing, we are using the always statement. We are using the always statement. So here what we are doing, so even always statement starts at time t is equal to 0. It starts at time t is equal to 0. Initial also starts at time t is equal to 0. Now, if you don't specify delay over here, for example, if this statement is not there and directly you are using clock is equal to tilde of clock. So there will be a problem associated with this. So we'll discuss regarding that also. Now we'll just come back to the always statement. So initial statement, you are initializing the clock value. You are initializing the clock value. Then always after every 10 time minutes, you change the condition of the clock. So if it was 0 previously, make it 1. If it was 1, make it 0. So what you're doing, it is like you are presenting the clock sequence. So 0, next it should be 10, next it should be 10, next it should be 0, next it should be 1, next it should be 0. So this continues. So this will be there for how long? It will be there for 10 time minutes. This will be there for 10 time minutes. So what is the time period of this one? Time period of this one is 20 time minutes. So if I come back to this case, right? So what I have, if the previous clock this thing was 0, then next this thing it should be 1. So again, if this is 1, next this thing it should be 0, and this should continue. So this is happening when after every 10 units of delay, because we are having hash 10 over here. So after every 10 units of time, 10 time units, there will be a change in the clock. So this is your clock signal. So if it was 0 here, after 10 this thing time minutes, it is 1. After 10 time minutes, again it is 0. After 10 time minutes, again it is 1, and it will continue. Now here, if I just see what is happening, so it will be 1 for how much time minutes? It will be 1 for 10 time minutes. It will be 0 for how much time minutes? It will be 0 for 10 time minutes. So total, if you just check what it is 20. So from here to here, if you just observe, after this again the clock is repeating. After this again the clock is repeating. So if you just see, after every 20 time units, the clock keeps on repeating. So the clock frequency set is 20 time units. You can make out that from this case. Yes. Time period of the clock is 20. So that is what he specifies. Now there is another initial statement which is present over here, which specifies hash 1000. That is, you have a task, this thing, task function, which is dollar finish. So it will finish the simulation. So now this gave you a hint of how we can go ahead by using always statement. So in this case, right, there is one important thing we should note down. Now, as specified, so let me call this as first block, which is related to initial, and let me call this one, which is related to the always. And there is another one, another initial. So if this is the case, right? So this is for initial block. This is for the always block, and there is another one, third one, which is the initial block. So it is related to this one, this example. So here you can see that the statement what comes is these all blocks, right? These all blocks start at a time t is equal to 0. That is, whenever you start the simulation, all the blocks start execute at time t is equal to 0. Now here, what we have to understand is this is executed once, this is executed once, but this is executed every now and then. That is, after the statements are over, again it comes back and it keeps on repeating. So where do we find the usage of such tasks is one example what we saw is the clock signal. So for your say hardware, right? Say if you're using a flip flop and you are giving a clock signal, so clock should keep on changing its state after a specified time period. So such kind of behavior should also be made available in your Verilog, that is hardware description language. So that is done with the help of using always block. So such kind of simulations can be done with the help of always block. Now initial starts at t is equal to 0, always starts at t is equal to 0, and this third initial also starts at t is equal to 0. Now suppose if I did not have this specification, that is a delay specification, what would happen? That is, in this one I have specified say clock. So the in this case I have specified clock to be 0. In this one it is the same clock is negated and used. And lastly, what you are specifying hash hash finish. You're specifying this part. Now suppose if you do not specify this delay, what will happen is at time t is equal to 0, all will be starting. At time t is equal to 0, what happens is here clock will be assigned 0. But at the same time, what is happening over here at 0 to this thing only, there is toggling condition. There is toggling condition of this clock. So now there will be ambiguity. So every 0th second, so this is executed once and this is done. But when you come over here, what would happen is you will not be able to set the clock frequency in a proper form. So at 0th second only it is on off. So that is how we go around. That is, it is either 0 or 1. So this is happening at this moment. And at the same time, you're specifying finish. So once it encounters this finish, it will stop the simulation. So what is happening? You're initializing, but all happening at same time. So there will be ambiguity on how to go around. So it will be the simulation will be stopped because of this statement over here. That is finish statement. So in order to avoid such kind of conditions, right? So which is not encountered in your hardware. Your hardware it is not encoded in this way. So what you do is here you have initialized and after some time unit always block is executed. After some time unit again always block is executed. It is not executed at 0. If there are some conditions which have to be executed at 0, that can be done. Now since we have taken an example of clock, right, we are specifying this. So 10 time units, clock changes its value. So previously it was 0, clock will be 1 over here. After 10 time units, clock will be 0. After 10 time units, clock will be 1. So this keeps on continuing. So this repeats. Now if I don't have this statement, that is this part is not there, then what would happen? If this part was not there, then what would happen is it would be in an infinite looping condition. That is, it will be continuously changing, but there is no stopping condition. That's why you are specifying this hash finish. So which is at 1000 time units. So here you are specifying from the start, right, at 1000 time unit, you stop the execution. You stop the running the statement, okay, running the simulation. So that is what you are trying to observe. So these are just a few things to note down with respect to initial and always blocks. So one thing, initial and always blocks are executed. Say if there are multiple initial, multiple always, all of them start their execution at time t is equal to 0. So whenever you are coding, be careful with such kind of aspects. So if you forget these things, then you might end up with say unprecedented results over there, unexpected results. Okay.